All right, everybody, we're back with review number 2 for our test that is planned for Tuesday. This review, I think, includes quadratic formula, complex numbers, and then a word problem. So 2 and 4 are both quadratic formula, and I kind of started setting them up. So if you look over on the left side of my screen right now in blue, the ax squared plus bx plus c equals 0 is the form a quadratic must be in before you use quadratic formula. And then the a, b, and c that you plug in come from the problem itself. So if you notice in number 2, to the right of the actual problem, I already solved it for 0. So I subtracted the 110 from both sides. Because 110 is a constant, it went at the end. And also notice that it's negative because I had to subtract it to get it on the left side. That should be algebra 1. So the quadratic formula side, now that it is solved for equal to 0, I can plug in a, b, and c. So in the quadratic formula, it's negative b. So in this first set of parentheses, I'm going to put a negative 9. That's my b. Plus or minus square root of b squared, 9 squared. Minus 4 times a times c, so that's 4 times 2 times negative 110, and all over 2a, so 2 times 2. When I go to simplify in the next step, on top, it's just going to be negative 9 plus or minus. I'm going to do the square root all at once, and be very careful if you have a cell phone calculator. Actually, I have mine out. I know you can't see it, but I'll use my cell phone calculator to show you how I'm going to have to do this in the calculator. So I'm going to get 9 squared, well, I know that is 81. And then minus, if I type in, I leave the minus, and I'm going to type in 4 times 2 times 110, make it negative. That gives me negative 880. Oops, it ran off my screen there. And I think we all know minus negative, this is going to turn into a big plus. So 81 plus 880 is 961. And we'll talk about simplifying that in a second. All over 2 times 2 is 4. I actually paused the video for a second to try to simplify the square root of 961, and lo and behold, it's a perfect square. So the square root of 961 is actually, let me erase this, without the square root. The square root of 961 is 31. So this is something unique that happens sometimes. I have no more square roots. I have no i's, no imaginary numbers. So what I can actually do with this problem is I can find both of these solutions. I can actually do negative 9 plus 31 and then divide it by 4. And I can do negative 9 minus 31 and divide that by 4. So this happens sometimes. This is a good thing. So negative 9 plus 31 divided by 4, I can do that and get one solution. So negative 9 plus 31, that's going to be 22, I believe. And over 4, so 22 over 4. Sorry, I'm running out of space. So this is now 22 over 4. And then that's going to reduce, if I divide the top and bottom by 2, to 11 over 2. And then negative 9 minus 31, that's negative 40 divided by 4 is negative 10. So for that quadratic formula, I got 2 nice real solutions. Now let's try number 4. Looks like it'll work out similar. I solved it equal to 0, but notice in the original when I added 4x, I put it in the middle because bx, or the term with just x, goes in the middle. And then I take these, a, b, and c, and plug them in. So negative b, it's my quadratic formula, plus or minus square root of b squared minus 4 times a times c, all over 2 times a. And then when I go to simplify, I'm going to get negative 4 plus or minus inside that square root, and be really careful again. That's going to be 16 and then minus. I keep the minus. And then in my basic calculator, I'm going to type 4 times 12 times 5. That's 240. And then 16 minus 240 gives me negative 224. And in the bottom, 2 times 12 is going to be 24. And this looks like it'll just simplify inside that square root. So let me take a second and pause this to figure out what's the biggest perfect square in 224. I'm back. I figured out, just pause it for a second. I figured out the biggest perfect square in negative 224 is 16. And let me just rewrite this again. So this is now the square root of negative 16 times the square root of 14. So that's the same thing as the negative 224. I just split it up. I know the square root is negative 16. The square root of negative 16, that's going to give me 4i. And then my one last step, now that I've freed that 4i from the square root, I can go ahead and reduce all of these. I can reduce the 4, the 4i, and the 24. I can reduce those all by 4. So if I do that, if I reduce negative 4 by 4, that's going to be a negative 1. This 4 is technically a 1. And 24 divided by 4 is 6. So my final simplified answer is negative 1 plus or minus I times the square root of 14 all over 6. And that's quadratic formula. I mean, sometimes the simplifying gets a little bit ugly, but it shouldn't be too difficult, at least if you show your work, to get most of the credit on the test on Tuesday. On to the next section of review number 2. That is discriminant, and then the number and type of solutions. Now, I made a video on this, or I think actually we talked about it in the Google Meet, so hopefully everyone got a chance to watch the Google Meet if you couldn't be there. And the discriminant is the part of the quadratic formula that's inside the square root. So I wrote it over here on the left. So this is the discriminant, b squared minus 4ac. And what that discriminant tells us is if we were to solve the whole problem, what type of solutions we'll get and what kind of or what type and how many. So for example, if I solve that discriminant and I get a positive number, that would mean my square root, let me scroll back up here. If I get a positive number like we did in number 2, that, I think it was 961, whatever that number in the square root was positive. And if you look at my answers, I got 2 real answers, no i's. If the number inside the square root is negative, so if you remember in number 4, inside that square root, I think it was negative 224. That meant in our answer, and if you see our solution, we got 2 imaginary solutions. One here in number 4 came from the plus and one came from the minus. Something that didn't happen in either of these two is if I get a discriminant of 0, that means when I add that square root, I'm only going to get 1 real answer because the square root of 0 is just 0. So in 5, 6, 7, 8, we're just doing the discriminant. And again, I wrote above the formula right here that I need it in standard form or equal to 0. So in number 6, as I go to number 6, it's already in standard form. So b squared, here in number 6, b is 0, because there's no x term, minus 4 times a times c. So I can already tell, even without multiplying, 0 minus this number is going to be a negative. And it looks like it's going to be negative 360. Oops. So if you get a negative number, so negative 360, that's the value of the discriminant. That means we're going to get 2 imaginary solutions. So if I were to solve the quadratic formula, I was going to get 2 answers with an I, something plus or minus I. Now let's check out number 8. So in number 8, I see, again, I solved it. I set it equal to 0. So I have negative 2n is my A, negative 4 is B, and negative 2 is C. So b squared, negative 4 squared, minus 4 times A times C. And if I simplify this, that's going to give me 16 minus 4 times 2 is 8, times negative 2 is negative 16. So that's going to change this to a plus. So I get 32. That's a positive number in the square root. That means my answer is going to have 2 real solutions if I were to actually solve the whole thing. So the discriminant is just a little bit less work. It's less than the entire quadratic formula. Last thing, I'm going to jump to the end of the worksheet. Also notice, I just noticed I kept 18 on there. We did 18 in review 1. So don't worry about 18. Number 17, though, I want you to try here, and I'm just going to talk you through it first. So in 17, it's the launch object model again, but this time I give you the information to plug in. So here's the model at the top. And we have to fill in for most of these letters except for T. So you throw a ball to your friend, the ball leaves your hand 5 feet above the ground. That's going to be the initial height of that object, of the ball here. So the initial height, or H0 at the end, is going to be 5 feet. And they also tell me it has an initial velocity of 50 feet. And we did some of these in class. That means the 50 is going to go in for V0. And then part A is asking me, so for this function, if I plug those in, this is what we have now. I'll start you off. Negative 16t squared plus 50t plus 5, because that was the initial height of the ball. In part A, they want the maximum height of this ball. So here's you and your friend. I know you missed my stick figures. So you're throwing this ball to your friend. I don't know why your friend's so much bigger. But they want the maximum height of the ball. So in terms of this quadratic, I know my drawing's pretty poor, it wants you to find the vertex. So I want you to try this on your own, just to see if you remember how to find that vertex, what the formula was for the x coordinate. You can look back in your notes, and then what you do to get the y coordinate of that vertex, because that's going to answer part A. Part B is looking for the final height. They say your friend catches the ball when it falls to a height of 3 feet. So that's now the final height. Everything else is the same. So this is now my function. So to solve this, they want to know the end height. Unfortunately, we can't solve quadratic formula when it's equal to 3. So your first step is going to be to get it equal to 0. And then use the quadratic formula like we did in the previous problems. So I want you to give that a try on your own, mostly because I have 15-minute maximum and I'm coming up to the end of that. So give it a try. If it doesn't work out, I'll send you my solutions back, and then we can talk about it on Monday at the Google Meet if you still have questions.